Hello everyone, welcome back to my channel. In this video, we are going to now learn further about pandas. Just to give you a recap of what we discussed in the last video, I gave you an overview of the pandas, what basically this package is popular for, and who basically use them a lot. Uh, Today we are going to deal and see technically what are the others data structures available in this package, and if the video does not go too longer, I will also try to cover one of the data structures in detail and share with you a ways to work with that. That's the goal. Let me give you an overview before actually getting into the coding part. Pandas has three data structures, and they are called, starting from the very first, called series. Series, it's an 1D data structure, 1D, and it's going to be an similar to homogeneous array. If you're aware of an homogeneous array or 1D array in NumPy package, series is quite similar to that, but with some added features, which is important for data manipulation. I'll talk about that. Second data structure, a very powerful, very efficient, very popular. That's called data frame. So data frame, you would have heard of it a lot. If not, get used to of it. This is going to be very, very efficient, used 99% of the time, of the 80% of the time when you deal with data cleaning, right? This is going to be a 2D structure. For simplicity, you can compare it with a data stored in an Excel, how the data looks like in an Excel, something similar data looks to be in a data frame. Or you, if you are from an SQL background, you can imagine a data in a table. So what are the commonness between all these data structures? They do provide 2D structure, and they are called tabular data. So especially while dealing with tabular data, you'll be, and whenever you have to manipulate your data, 90% of the times you'll be working with this package called pandas, and out of that, again, 90% of the time you'll be working in a data frame, of course in support with a series, and that's why we need to know about series and its properties, functionality, manipulation, and so on, before moving on to the data frame, which I'm going to cover in detail. The last is the last data structures that's provided in pandas, that's called panel. Well, a lot of you would have not heard of it, and because it's not that popular. And do we even need to know it? Well, the answer I is based on the industrial uses, so we may not need to learn this, and that's okay. At this stage, industry is heavily and extensively using your data frame in combination with your series. What about panel? That's not required. Why not required? Since it's supporting 3D, don't we want to work with a 3D data or 3D level of arrays? Of course, we want to work, but we have already got a very good frameworks that supports higher dimension data handling, right? And those are already popular. So when you say 3D, okay, so 2D data is compared to a 2D data structure like in a table or Excel. What about 3D data? Which are the, do you have an example for 3D data or higher dimension data that you'll be dealing with? So those are nothing but unstructured data. The data that you have in a table or a data frame, these are called structured data, right? And the data that you'll see unstructured, these are nothing but your images. Images are an example of an unstructured data, video, audio, text, and so on. So in today's world, of course, majority of them are unstructured data, still unexplored fully, because of the fact we were lacking a good tool to handle them, to work with them. Having got many deep learning frameworks like PyTorch, well, initially we got Theano, then came Keras, then came TensorFlow and Keras, and then now a very popular framework is PyTorch. Once these frameworks have come, now these particular data are extensively explored, for the fact that yes, we have a tool, we have a high processing power, and we also have a way to parallelize the processing, which were lacking before. But irrespective of that, even today, for the 2D data handling, what is most preferred is a Pandas data frame itself, or Pandas data structure data frame, which is still very popular. And it's also a fact that 2D data, which is tabular data, has a lot of its own challenges, especially when it's in raw form, just directly collected from web scraping or through any data mining mechanism. So you really have to understand them, look into their, when you see an image, video, audio, text, they are quite self-explanatory from human understanding perspective. But when it comes to table data, they are not self-explanatory until you really go and summarize them up. So there are a lot of tools provided, to lot of mechanism, a lot of techniques available using which you can summarize them, and there are also a lot of guidelines available that you can use to basically understand or infer or draw insights from the data. So we are going to see or learn all of them, but at one at a time. Hopefully now you are clear about the available data structures that we have in pandas, and why panel is not that popular at this stage, although it supports higher dimension, which is 3 dimension of data. Now, let's go and see quickly a series in detail. What a series is, how does it look like, why it's even called a series, what are its properties, what you can do, um, how can you manipulate, and so on. We'll take all these questions with examples. Right. To work with series in Pandas, let's quickly first install this package. If you're a first time user, you have to install Pandas package, which will not be installed by default. And then you can make use of any functions or data structure in this particular package. So you can install it with the command exclamatory marks pip install, and then the package name, that's Pandas. Once you have this code, just run this. If you don't know how to run a code through a keyboard in Jupyter Notebook, please do watch Jupyter Notebook video, and you'll be better aware with all keyboard shortcuts working with Jupyter Notebook. Now, coming back, in my case, since I already have installed a Pandas package, you see it's saying requirements already satisfied. However, if you have a first time user, it should install for you, take quite longer to install it, right? Once you have installed it, you have to import it, import any package to make use of all the methods out of it. So I'm importing, import pandas. So this much of code is quite sufficient. You can call pandas dot any method in it. However, I will give an alias to it called PD. PD is a short form, mostly nowadays abbreviation form of pandas. Very popular symbol to be used. Uh, However, if you think you do not like PD, you can also take any other name, that is totally okay. But I would choose to use pandas. So whenever I have to call pandas, I'm going to call it with PD. Be careful about that. I have run the code again. Now I have the pandas imported in my environment. I can now see and all the functions or anything inside this package. Let's do that. How to do it? So before going there, I just want to give you one more overview. This is important. When you run this command, basically this command means display, find the length, count the number of object inside this package, inside pandas package. So whenever you are going to do that, in my case, the count is 142. It can vary in your system. That is totally okay because the number of objects in a package can keep on changing depending on the version of pandas that you use and even the Python. So do not get worried. The number can be a little higher for you, a little lower. That's okay. What is important is this one. So if you want to see the series method in the package, you have to go this way. PD dot capital S series. It's not CD, it's series. So now that should give you a blank series object. If you're not sure why these informations are there, be with me for some time. I'm going to explain. Now, let's see the documentation of series. You really have to pass some values to it. It's a series is nothing but function, basically a method that helps you to create series object, which is one of the data structure in pandas from the data, any other data that you have. The first important parameter for series is data itself, which represents, if you're not sure, you can read the documentation. Data can be any valid array-like object or it can be an iterable. So in Python, we have list, tuple, set, strings, iterables. So any iterables, it can also be a dictionary or it can be a scalar value like 1 to 3 or floating point 2.2 and so on. So you have to pass one of this data, existing data in each of this or one of this form to create or generate series out of it. Now, index is a column that basically would be difficult for you to understand at this point of time. Let's see one by one. Let's today continue with how does it looks like to create a series from an array and rest of the supported data structures. And what is the advantage overall of using series unlike an array that we should work? To do that, I really have to import and create an array. So let me get an import numpy as np. And let me show you how an array looks like if you haven't seen it even once. So I'm going to create an array from a numpy package. And let's say create it out of numbers 2, 3, 8, 5, 2, and so on. So these numbers I have chosen randomly, no logic as such. That's called array. This is array. So if you ever remember the properties of an array has basically this is 1D, although NumPy supports n-dimensional array, but what we have on screen, that's one dimensional, just one dimensional, not n-dimensional. Okay, so this is an array, and you see an array is an homogeneous data structure, and the most important, what happens for every element, you get distinct index number starting from 0 to n minus 1, going from left to right. So what that means, when you move left to right, first 2 is at index position 0, then 6 is at index position 1, 8 is at index position 2, 3 is at index position 3, and then 2 is at index position 4. Since we have total of 5 elements, so the indices goes from 0 to 5 minus 1, That's 4. Now, this is understood to be there. You don't see them here on the screen. However, this data is always there, understood to be. So an array, for every elements you have two properties, one the value, which is 2 in this case, and the other the index position, which is 0, right? That's it is. Now, but the indices are never shown on a screen. We have to assume it's always there, and we can do our rest of the processing based on that. Also, you cannot change these indices. These are the default and only values, always going to be in terms of uh, integer number. You cannot change them. What if I wish to change them for my better readability so that it makes more meaningful for me? I can also see not just my number values but also the indices along, so that I can better, I don't have to every time count. If I really have to know what the indices of 3, you saw I manually counted it and then I mapped it with 3. So but what if I don't have to do, I see them, if it's already printed below, let's say 3, I don't have to every time count it from left to right. I can just go through it, right? So that's what, these are the two shortfalls of array. Although array is a very powerful, high dimensional, high processing data structures, specialized and for numerical computations. And so on top of the array, and whatever you have the properties of the array, that's already retained. But on top of that, it has also involved encapsulated a better representation, a better display. That's what is offered inside your series. Let's quickly see with one example. So I'm going to create now on the same data, which is a list. From using this data, I'm going to create a series. If I have to create, I just have to say data equal to this one. Now let's have a look. Let's see, I save it like S representing series, and then I have the series displayed. Now, you see that's called series. This is an array. That's your array, but this is your series. What's the differences between them? As said exactly first, the way data is being displayed. In case of array, you could see your data points aligned horizontally, but in case of array, in case of series, it will be vertically. That's the one difference. Okay, second, you see there are two data points running, two columns standing side by side, adjacent to each other. So the very first one, the one pointing here, that represents your actual data values like 2, 6, 8, 3, and 2. The first left side columns that represents indices we talked about. So 2 is at index 0. That means what? That means 2 is the first element of the series. Then 6 is at index 1. That means it's the second element of the series starting from left to right. And so on. Again, 2 is the fourth. 2 is again occurring at the fourth index, which is fifth position, going from left to right. That's the difference. Now, so does this difference has only to do with terms of visualization or something else? So as I said, series combines high processing power of NumPy array, plus on top of that, it gives you a better representation. This is better? Because you can also simultaneously see what are the indices. Every time you don't have to read it through or count it out, you can actually see on the screen. So now if somebody asks me, okay, tell me what's the index of 8, I can very easily say, oh, it's 2, it's written here. But here, if I have to do that, I know a lot of you can do that very fast, very processing, but understand, if you have 20 elements and you have to find some element value which is at somewhere in middle, like 15, between 10 to 15, you really get sometimes confused. You have to count to validate your answer and then say it out. But in case of series, I can see along. I'll be doing the task very fast. So what is the advantage of series? It's not, of course, it's utilizing the high computation computational power of your computer, but even for a human being, it's making easier to better read the data while analyzing it. So that's about the series, right? Hopefully it gave you some idea. Let's try to see, as I said, there is one more advantage of series. Let me give you that too. The same data, this time I am somehow not okay with reading my index like 0, 1, 2, 3, because it's kind of confusing me with my data. My data is also in terms of integers. Some values 2, 6, 8, 3, 2. My indices are also in terms of integers, and that's confusing for me. It's not making sense. I want to change it. I want to give it like ABCDE, which is a string form, which makes more sense to me. How can I do that? So you can do it by passing your index parameter. There's a second parameter called index. What you can do is you can pass here a list of the labels that you want to assign to your data. Let's have a look. If I run this code, how it looks like. There it is. What's the difference you see compared to the top ones? Your data field is as it is, that's completely not changed, which is the second column out of the two columns standing adjacent to each other. That's the data. But when it comes to your indices, look at the indices, that's completely changed now. In the previous case, the indices were the default values or default indices, which is nothing but numeric representation from 0 to positive integers. But in case of here, now these are the labels that I assigned. My labels are nothing but the alphabet letters, but it can be anything else that you wish. So now it's A, B, C, D. Now it's more better for me personally, for me to better understand. So a lot of the times you have to choose your levels, maybe sometime based on your personal preference, and if you're processing, a lot of the times it will be technical constraints or better data handling, better data management. That's how you choose. So, right. Now, you might be wondering, so why did I pass it like this and how do I understand? If you notice, I got an error too. So why was that error for what that mean? Let me give you some possible scenarios you can come up with and you can get some error. So what does as per documentation, if you go, what it says, your list should be your index should be a list object. It's a list object. Now it's up to you how you create list. Either you create the above way or you can create it this way. I can explicit go and pass list A, comma B, comma C, comma D, and comma E. This will also work. It's all that you have to manually type each one of the elements. Right now you just have 5 elements, makes sense. But again, if you are working with 500, that would not make sense. So you can also generate it somewhere if you know you can call any function also that can generate your indices, and but the final function object should be a list object. That's the only requirement. So from this it has assigned the levels. Now, so the next question that you can have is, so what about the default indices like here? Are they lost? Are they completely lost? Now they are no longer valid since I gave a new set of levels here. And to answer that, the answer is no. Whenever you provide, this is called leveling. Okay, Labelling. That's the one. You provide labels to the indices. You are providing customized names to the indices. So, what happens when you provide customized names? The default indices like here will still be there down in the backend, but on top of that you are also adding a better names standard for your better readability. So in case where you have both where you have levels, you can still read the data through default indices like this, as well as through the levels like this. I will show you how to do that in some time, but I'm letting you know that whenever you choose levels or passed through index parameter, you have some extra benefits attached to it. But there is a disadvantage also, which I will highlight at the same time. Right now, let's move on and continue with how the series looks like when you try to create it with other data forms like from an array or from a dictionary. Let's see one more. So this time I'm going to create the array. Now create the series. Let me add it. That's from an array. So instead of passing a list, I'm going to pass the array that I just created over here. This is an array object, which is 1D array. And this is how it looks like. So yes, if you have an 1D array or 1D list or 1D tuple, you will not see much difference. You can, these all datas are quite supported, and these are iterable objects. You can pass them. Let's see now next, which is creating an series from a dictionary. So assume you have a dictionary called D, something like having name equal to Peter. Or rather, I think that will not make sense. I'll can do, but let me give you some better example. So val1 equal to 1, val2 equal to 6, val3 equal to 8, val 3 5 sorry, that should be 4, equal to something 9, and so on. You can keep on growing your number of elements in the dictionary, but I keep it very short. And now I have to create a series out of this dictionary D, and this is how it looks like. Clear? So what's happening in case of a dictionary? When you pass a dictionary as a data, it is recommended that you do not pass the index argument. Although index argument is always optional. For example, in this case, I did not pass. So whenever you don't pass the index argument, default indices will be picked up, which are nothing but in numbers 0 to n minus 1, like here. It is also recommended that you do not pass index parameter with a dictionary. Why? Because dictionary has its own value meaning or its own benefits with the key value pair combination. Every value should have a corresponding key which should be unique itself, so you don't have to literally pass your customized levels. The dictionary keys itself will be the customized levels. So in this case, your dictionary keys forms your indices and the filled values goes as a data. Is that clear? Hopefully. Now let's see what happens if you have to create a series from a scalar number. So this time I have some scalar number like anything you choose up to you 20. I want to create a series of certain length with all elements as 20. This is as simple as that. But the problem here is, you see, it gave me a series of a single element, only one element. What if I want to create a series of length, some say 5, and with all elements value being 20? Maybe you want to do it for an initialization purpose. That could be several purpose of that. But technically, if you have to do it, how can you do? So in that case, you have to, in case if you want to enforce the more than one elements to the series with a scalar value, like in this case, now it will not be 20. If you want, you can also take minus 20, minus 30, or you can take 20.3, anything you wish. As long as it fits into an scalar value definition, it's good. Okay, so if I have to extend or enforce more than one element generation, I have to pass list parameter, sorry, index parameter, and that should be a list object. It's up to you how you generate your list, but the final object should be a list object. And here, let's say I say, okay, look, I want to generate 0, 1, 2, 3, 4. So basically 6 elements, and there it goes. So now I have 6 elements, 0, 1, 2, 3, 4, 5. Okay, and all of the elements values are same in this case, right? So here we took, to summarize with, we have created by now a series using list, array, then dictionary, and scalar values. So now tomorrow, if you come across a situation where you have to create a series from out of these values, you should not be wonder lost to understand how that will look like. And if you have to even pass and customize levels, or what it's called leveling, you can do that very efficiently. Now, once you have created a series, the next task could be reading out the elements. For example, there could be an option like, I want to just read first 2 elements. I want to slice that out and store as a new object. How to do that? How to change a value? Let's say now I'm willing to change the value of the fourth index, fourth element, third index, something else. How can I do? So that comes under replacing or manipulating the list series values, which we'll see. And then there could be operations that can be performed on a series. So all I'm going to cover in the next video. Do watch that. Until then, you have a happy learning.